Dear friends of the Delphi Economic Forum, ladies and gentlemen, my name is Alex Lagakos. I'm the COO of Blue Grid and the Vice Chairman of the Greek Energy Forum. And I would like to welcome you to a panel discussion which is sponsored by the Greek Energy Forum as its content partner and which is focusing on new energies and on innovations around energy. So although innovation requires us to think outside the box, let me please try to categorize innovation into two main categories. The first way to innovate is to invent a new means to achieve an objective. The second way to innovate is to use an existing means in a new way in order to achieve an objective. And this exactly is going to be our main compass for our discussion during our panel today. So given that we host today a very diverse set of panelists and experts, we are touching upon a very broad topic, we need to keep our discussion as much structured and as much coherent as possible. And therefore, we will gonna be orientate ourselves along two main dimensions. The first one is talking about the future energy carriers of tomorrow, such as hydrogen, biomethane, renewable gases, e-mobility, and other examples. And the second dimension is gonna be talking about the future use of today's energy carriers and technologies, such as small-scale LNG, photovoltaics, and energy storage. So before we kick off our discussion, let me inform you that we have a last-minute change, and Mrs. Mettler, the Vice President for Europe from Breakthrough Energy, unfortunately has informed us that she had to cancel her participation at a very short notice. So without further ado, let's start with the first question of the panel. By the way, we have chosen to make this as more interactive as possible with the fellow panelists. So I'm going to start with our first speaker, Sjors van der Rijt, who is the General Manager of Tech Sector of Renewables and Energy Solutions in Shell. Sjors, welcome.
Thank you, Alex.
With us. So the first question is...
Can you hear me well?
Yes, yes, we can. So the first question is the following. So somebody could argue that we are entering some sort of a renaissance period for hydrogen as a net zero fuel. And the question is, how distant do you think we are from that target? Is it all hope? Are there perhaps other renewable gases that we should also take into consideration?
Thanks, Alex. There might be a little bit of a delay, so I'm just going to test how this works. Can you still hear me? Can you still hear me?
Yes, we can.
There you are. Okay. So, look, thanks for your question. I think it's a great and really important question. And you know, we've been at Shell, I think, for many years, a true believer in hydrogen as a solution and as a vector in the energy debate, and we see huge opportunity in it, and that is why we are committed to its development. Yeah, both as a storage vector for renewables, and we talk about that maybe a little bit later on, and of course as a net zero energy source for commercial customers, for industrial customers, and for different forms of transportation. So definitely not a hype, and really importantly, I think the world is now aligning around net zero, and you know, there's critical examples of industrial decarbonization through hydrogen that are starting to take shape. It's really different from before in that the EU, for instance, has baked hydrogen firmly into its policies for decarbonization. It is widely accepted that there's a big role for hydrogen to play, and this was really different just 10 years ago. And when I started at Shell 15 years ago, we already had a business development manager for hydrogen sitting right next to me, for instance. So I think if you look at the EU hydrogen strategy, for instance. Yeah, this asks for at least, I think it's 6 gigawatts of electrolyzers installed in the EU by 2024, running on green energy. Yeah, this includes our refine electrolyzer in Germany, which will produce 1,300 tons of hydrogen a year after completion. And working examples like this one and other ones will start to build the case for hydrogen that in turn will then stimulate further understanding and interest in the potential of hydrogen. I mean, I'm going for a little bit. I think in the US, we are working with Toyota, with the state of California, to deliver 7 new stations in an area where there's high demand for hydrogen fuel cell trucks. In the Los Angeles area, and we've received a proposed award of more than $40 million to build 51 new refueling stations in California as well, right? And what you see is that in line with that, then you see companies like Toyota and Honda and others introducing new fuel cell electric vehicles to the market. We're opening hydrogen fuel stations here in the Netherlands and elsewhere. We invest in Zero Avia, which is a company trying to get planes to operate on an electric motor driven by fuel cells. And even in China as well, we've started a joint venture where last year, including a 20 megawatt electrolyzer, was agreed, which will be powered by wind and solar. And really important, I think, to come back to your earlier point, is that in all these endeavors, there are partners and governments and policies and regulations that make all of this possible. And we have to all work together to really make hydrogen a success and benefit from all the possibilities that it offers.
I fully agree with your last statement, Sjors. So we heard some examples from the US, from the Netherlands, from China, and I'm turning to my right to address the next question to Ms. Maria Rita Galli, who is the CEO of DESFA, the Hellenic Gas Transmission System Operator, and ask her what does DESFA do in order to support the country in embracing hydrogen as a fuel.
Thank you, Alex. And first of all, I would like to resonate what Sjors just said, that is, let's say, this is really the momentum in which there is a huge potential for hydrogen in Europe. And of course, we are all focused on promoting the development of green hydrogen, and Greece having, let's say, abundance of renewable energy through solar and wind have certainly a big space to play in this future development. When it comes to us being the operator of the natural gas transmission system, of course, our first priority is to ensure that our network is ready to accommodate hydrogen. So what we see as a trend as a path will be that in a first step, we will most likely have hydrogen blended to natural gas and with increasing percentages. And of course, our focus today is twofold. On one side, on the existing grid to make sure that we identify clearly the very limited investment that we need to make it fully hydrogen ready. And we have already participated to an European study carried out by DNV on behalf of Restream, which has produced a very positive result on the fact that the vast majority of the in Greece is fully ready to transport hydrogen. The same result has been delivered to us by a study which has been carried out by Democritus National Center for Scientific Research. And so the next step will be really to carry out a detailed gap analysis and identify not on the pipes, but mainly on compressor station valves, which are the adjustment needed to reach, let's say, from 2 to 10 to 20% hydrogen blending. Next phase will be to develop a dedicated hydrogen backbone. And in this respect, I think I can quote, because it's publicly known, the project to which DESFA is a partner, that is the White Dragon project, which has been really recently submitted in response to a call for tender by the Greek government. Is a very large-scale project, and I'm very happy to say that there are 10 Greek companies, all together joining forces to create an integrated value chain from production to consumption, and where, of course, we will be, our role will be to facilitate this development, as I said before, first of all, by blending natural gas, hydrogen into natural gas in the first phase, but very soon also to develop a dedicated parallel for certain section line, because in Greece there is already quite significant demand of hydrogen, and is pure hydrogen for refineries and for fertilizers, which today use grey hydrogen. So there is really demand, and there is a huge potential for supply, and as DESFA we want to be, let's say, the infrastructure player which will enable supply and demand to be connected for hydrogen, as we have been always doing for natural gas.
Thank you very much. And before turning to the politician of the panel, I would like to thank the speakers so far for really honoring our agreement, which is to limit their answers to 2.5 to 3 minutes max in order to maximize the number of questions that are going to be asked. So I'm turning to Frank Fannon, former Assistant Secretary of State for Energy Resources in the US. Thank you for being with us. And since we're talking about e-fuels and hydrogen and renewable and green energy, would you agree, or how would you respond to the statement that probably topics like that remove gradually energy from the toolkit of diplomacy?
Yeah, thank you for having me on. It's delighted to be with all of you. I absolutely don't think that it takes the greening up of the policies takes this out of the toolbox, the diplomatic toolbox. I mean, I guess, in fact, I would suggest that it makes it more complex. It makes it more challenging. The concept of energy diplomacy was really one born out of the modern era in the aftermath of the oil crisis, where you saw a level of market concentration of energy. At its apex, OPEC only controlled about 50 to 55% of the global demand, or the global market for oil. Moving to the energy transition, it actually makes it that level of dependency more complex, given that we're talking about nascent markets that are relatively opaque, illiquid, and the level of market concentration in both the production of the minerals as well as the processing is a high degree of concentration. So we have to reconsider how we approach these questions. They're absolutely critically important. And the effect is having effectively a regionalization of clean energy supply chains, which you see North America pursuing. Europe is very much doing the same. And in both regards, there's an increased awareness and recognition and consideration of issues such as environmental quality and human rights as well. And these are critically important initiatives to continue and to strengthen, to ensure that the energy transition really is inclusive of all people, including the areas where the minerals come from. This is something that the Biden administration understands. They're continuing some of the programs to support these initiatives from the prior administration, a degree of pragmatism, because there's a recognition of the role, how the energy transition has a broader potential of both market concentration issues, but also how to level up the optionality for new energy systems and technology and increase the pace of deployment of these technologies and do it at scale. Thank you. Thank you.
Thank you. Thank you for your answer. And speaking of policymakers and meeting the net zero target, I would like to turn to Dr. Anna Korre from Imperial College, co-director of Energy Futures Lab. Thank you for being virtually with us. So, apart from the big progress that has been achieved during the recent years regarding the electricity system, what are the remaining challenges and therefore some examples of applications that could inspire our policy makers in the region in this effort for making the energy transition a reality?
Thank you, Mr. Lagakos, and also delighted to be here with you today. I would say that we have already heard that there is substantial interest and engagement in what is important in the Greek sector by a fellow panelist from DESFA. So in my opinion, the emphasis must now be on the difficult to decarbonize sectors, but also on the need to have a whole system view, a holistic solution for several sectors. And I think that as decarbonization reaches deeper into our society, we have the need to make behavioral changes and engage with people, engage with society a lot stronger. Notably, of course, in transport, but also in building, heating and cooling, which is very important in our country. Of course, we know that there are important issues to think about that relate to energy storage solutions, the consideration of producing sustainable fuels from renewable energy, like we heard, hydrogen from wind, and next from solar energy, and enabling the hydrogen economy to thrive. But moving on further on from hydrogen, ammonia is potentially an important vector that we can consider particularly as a next generation shipping fuel. And to make all of these interesting opportunities a reality, what we have to use are the latest tools in digitalization to allow us to facilitate this energy transition and to engage more deeply in the decarbonization.
Dr. Korre concluded with mentioning another buzzword, which is digitalization. And now I'm turning my head again to Sjors from Shell in order to help us familiarize ourselves with digitalization of energy and what it really means. Is it an efficiency enhancer or for the energy industry, or is it a true enabler for new products and new customer value propositions?
Yes, thanks, Alex. It's a good question. I think it's both. You know, when it comes to digitalization and technology and energy, you know, the world is really at an inflection point. And previously, what you saw is silos of technology sort of developing in isolation and at different places. You know, whether that be for wind or for solar or for hydrogen, but that's all changing. And the integration of different energy carriers and systems is more clear than it's ever been. And it's really important to connect all these different pieces of the puzzle, which is also what we're trying to do, right? So let me try and make two distinct points here. I think one is digitalization is absolutely crucial for achieving the world's ambitions in addressing climate change. Without smarter ways of running the system, we will simply not get to where we need to be. Yeah, so the old sort of one-directional way of generating energy, and specifically power, that cannot continue to be the answer for grids that have to deal with much more complex you know, systems and groups of energy coming onto the system. And they're going to have to integrate increasing amounts of renewable energy. They will continue to develop to be more local, more distributed, and you know, in order to satisfy all this demand for clean energy. The grid will really change, and that's where digital solutions really come into play. You know, they can help grids, but also energy users deal with these different profiles on a much more local level. So you know, that they're responding to the demand quicker, more efficiently, better, and all of this has a huge role to play in creating the transparency, the connectivity, and the sort of, you know, ability to run the grid efficiently. I think that is one crucial role that digital has to play in the energy system. I think the other point, which you said is it one or the other? The other point is that it does enable new solutions, right? New types of products in these markets. I mean, for example, smart usage of such small-scale assets by pooling them to create virtual power plants is made possible by smart technology and algorithms. You know, like for instance, the company Next Kraftwerke, which is subject to approval by the authorities we've acquired earlier this year, and you know, they bring more than 10,000 decentralized energy units together, from solar to bioenergy to hydropower, and they make sure that the energy of all those small little assets can still be traded on the wholesale electricity market. And such physical and digital convergence really enables anyone to monetize assets in a totally different way. And that's also true for consumers, which we may get to later.
It's a true reshaping of the energy sector indeed. So I'm turning to Mr. Zheng, Director of Central Eastern Europe Regional Division from Huawei. Thank you for being with us. And I'm going to ask a similar question. So what are the customer value propositions that digitalization of energy unlocks for your company?
Thank you, Alex. Thank you for the questions. And dear friends, that now digital transformation and carbon neutral are driving the development of the energy infrastructure. So we are support the many customers to achieve green power generation and also has efficient power consumption. This is very important that we can promote the digital transformation and the development of the digital economy. So we are committed to leading the energy digitalization for a smart and sustainable world. Now we are bringing the digital to every PV plant, to leading site energy digitalizations for everywhere. We strongly believe that technology would help us make positive change to deliver this sustainable future. So for green power generation, our target is to achieve higher yields and more efficient operation maintenance. This is really important to reduce the LCOE of the PV plants, and also this is important to reduce the cost of the electricity bill of distributed users. So this enable the solar energy to become a main energy source in the future. So we have integrated some like intelligent and advanced technologies, such as like for inverter, mounting MPPT, and with some intelligent tracking algorithm. So this can enhance the energy yield by more than 2 or 3%. And also we have integrated like smart like IV curve, which normally you need to send the people and the operator onto the site to check the panels. And normally it takes like 40 days to check like 1 megawatt, 2 megawatt site. But now we use this IV curve scanning. You can remotely scan it in 15 minutes for 100 megawatt site. So actually this is extremely efficient, and think about this will save a lot of cost for operation maintenance. And also for householders, we have the optimizers, which can generate more yields, that's up to 30%. And also now the storage system is really important to achieve 100% green power utilizations. So another topic is about like data centers. Data centers also are fundamentals for digital transformation, but they consume a lot of power. So we has transferred some traditional data centers by reshaping the architecture, cooling, power, and the operation maintenance to reduce power consumption. So to build a simpler, a greener, smarter, and more reliable data center for our next generations. So far, our green power generation is almost 300 billion kilowatts has been generated, and 10 billion kilowatts electricity has been saved for the consumer. This is almost equivalent to plant 220 million trees on Earth. So our ambition is to lead the energy digitalizations for a smart and sustainable world. We believe Huawei digital power will create business value for operator, for our customers, and contribute to the overall society.
Thank you very much. Dr. Korre, a bit of a provocative question. So it seems like we've been assessing all the energy relevant endeavors in terms of their carbon content and in terms of their tank, and focusing on a tank to wheel perspective, more or less. To me, it feels like in this way we might be neglecting some the life cycle impact of currently attractive looking energy solutions. So my question is, if we were to reset the public energy agenda based strictly on a full life cycle assessment of everything, do you think we would expect a major recalibration of the European energy policy and agenda?
Yes, this is a very important question. Now, as an environmental engineer, I'm acutely aware that all human activities induce impacts. Impacts being emission, pollution, toxicity for the ecosystems and for humans. But for us to allow such activities to take place, it must be that such impacts and the risks that they may induce are tolerable. We must consider them tolerable. Of course, when we protect the climate, energy-intensive activities will actually attract trade-offs and impacts in other environmental compartments, be it in water or in utilization of resources or ecotoxicity or emissions. Now, typically, what happens is that we would like those impacts to be in compartments that are not particularly threatened, looking at resources, affecting resources that are not so critical. Sometimes we even tolerate that those impacts should occur in different parts of the world. So, for example, let's say electrification. We think about lithium production and copper extraction in South America. It happens perhaps very far from Europe, or cobalt extraction in mines in Africa, or rare earth extraction in China might appear very far from European users of vehicles who have an option to choose between electric vehicles as compared to their usual conventional fossil fuel based internal combustion engine vehicles. I would say that in my experience, these issues were not very well understood, say some 20 years ago. And in those days, the environmental assessment was a poor relation in general to the health and safety departments within industry and corporations. Now what we see is that the climate emergency has actually brought a completely new reality with the environmental experts sitting within the executive board of companies. And I would say that if we think about European policy or European government's policy, until now, strategic decisions have traditionally been based on economic considerations and given certain geopolitical and resource supply and demand constraints. And even in individual countries, our consideration of impacts has had a local or sometimes, in better cases, a regional focus. I think we are now witnesses to a paradigm shift. We now know and we also can account for impacts throughout global value chains, global supply chains. And in my view, global warming potentially is the first life cycle assessment indicator that is being seriously considered in energy policy decisions. It might even lead to a price for carbon, which is underpinned by evidence and data. I expect that in the future, other indicators from other environmental impact categories will follow and will also be considered. And at that stage, we will need a recalibration, obviously, of priorities. But I think that this recalibration is not going to be in the opposite direction. I think that actually is going to be something positive and is going to require some adjustments. And definitely we are ready to manage those. And also globally, we're so very well connected now, and information is allowing us to communicate and share information, resources, everything. I think it will be a lot easier for us to consider in a life cycle dimension the impact of different energy endeavors.
Thank you. And I'm turning to Mrs. Galli. One great example of negative well-to-wheel emissions for a fuel is biomethane, especially when this is produced out of waste. So let's talk about this fuel of the future. And again, there is consensus that there is great potential for Greece in order to play a vital role in the production of biomethane in the region. Again, similar question to my previous question. How does DESFA can support the launch of biomethane and bio-LNG in the region?
This, for me, it's really a very important question because you call it biomethane a fuel of the future, but I think it's very much a fuel also of the present because, let's say, this is really a very low-hanging fruit, which is not being, captured today, certainly in Greece, but still in many parts of Europe. I think that, what Professor Korre mentioned before about, let's say, some refocusing of the overall energy strategy comes also in the debate between electron and gas vehicles. And let's say what is growing in terms of awareness is the fact that decarbonization will not pass only through electrons, and we will need some gas energy carriers because they will have to serve different needs. Of course, there is going to be hydrogen in the future will play a very important role, but will not be able to solve all the needs that, of course, are to be covered by gaseous energy carriers. As DESFA, we are a member of Gas for Climate Association, which has published in the last couple of years quite an extensive study of the potential of green gases in Europe. And when we come to biomethane, the number is quite striking. Europe has a potential to produce from the current 20 terawatt-hour to approximately 1,100 terawatt-hours in 2050 of biomethane from waste, which is more or less 20% of the current gas demand for Europe. Biomethane is very easily produced by anaerobic digestion of humid biomasses, and this means also introducing elements of circular economy because really you can produce energy out of organic waste from agriculture as well as wastewater and urban waste. So looking at Greece has a total biomass potential which is approximately 5.7 million ton equivalent per year of humid biomasses. Today, approximately only 20% is used, and is only wood biomass which is used as pellets in the production of heat and electricity. So the remaining 80% is completely unutilized. And the utilization of humid biomass with all the conversion factor and losses would lead to the production of approximately 1 billion cubic meter of natural gas per year. If all the biomasses are utilized, that would again be more or less 20% of the gas demand in Greece. Of course, humid biomasses production is concentrated in certain regions, in particular in the agricultural ones, so the region of Thessaloniki, Larissa, Evoia, Ioannina, Serre, Drama, and Attica, and we need to take into account also the proximity and the concentration to be efficient. So scaling down significantly the potential, we would still reach approximately 500 million cubic meter per year. So, and on top of that, there is the possibility, of course, to recycle the waste, and of course, Attica and Saloniki, where 45% of the Greek population is resident, will be, of course, the best location to develop biomethane production out of urban waste. What needs and what can be done, because really Greece has zero biomethane production, a little bit of biogas, but zero biomethane production. Of course, we need to have a good regulatory framework in place that enable biomethane to be injected into the network. And of course, we will, as DESFA, work also to promote these regulatory changes in order to facilitate the production and injection of biomethane. Looking at energy policy, this is more broad at European level. Of course, if we would have some mandatory targets, like 10% of all the gas by 2030 needs to be from renewable sources, then of course we'll create a big acceleration in the production of biomethane. On top of that, we can also play a role as an aggregator, and we will think about that very seriously in order to let's say, create sufficient critical mass with the producers of this biomass and promote the development of biomethane plants in Greece. And I would also raise a commercial angle, because if you think about the fact that we have the possibility to deliver LNG, liquefied natural gas, on trucks and in the future on ships, through the introduction of some virtual liquefaction concept, producers of biomethane will be able to sell bio-LNG. And why bio-LNG is different from biogas? Simply because it can serve a premium market, which is the transportation sector. So there the competition is with diesel, with gasoline, which are not only much more polluting, but are also more expensive. So there is really a market there to be captured, and there is a potential that we hope we will be able to contribute to develop in the Greek market.
Thank you very much. I will ask in this final round of questions for the speakers to try and limit their answers to 2 minutes. I will also try to shorten my questions as well. I'm turning to Zheng. Most of the discussion in regards to green energy and renewables so far has been primarily focused on the incentives and on the national targets. However, little focus or less focus has been given on the necessary electricity grid upgrades or the electricity bill savings mentality that needs to develop. So with this question, how can battery storage system expedite the necessary transformation of the energy market?
Thank you, Alex. So we all know that now, nearly 2/3 of the world's economies are now moving to zero carbon or low carbon economies. And a lot of major countries have set up goal to being carbon neutrality by 2050, and even some is early. So energy storage has become very necessary to solve this challenging because of the higher renewable energy access to the grid. And it's also the concerns of the electricity safety. So as the penetration of new energy source increase, the power grids will have higher requirements for like frequency regulation, peak shaving. So in the meantime, battery cost will be decreasing with the technology advancement. So with these two combined, that we project that energy storage, work with PV systems. This will become a very critical component. So we has looking at a trend, the proportion of PV systems coupled with energy storage will exceed like 30%. So the cost reduction of energy storage system cannot be solved by the single battery industry. We believe that we need to integrate like battery technology with the electronics technology and some intelligent technologies to monitor and control, to rectify the energy output. This need to reconstruct the energy storage system. So we should also improve the availability, the capacity of the energy storage system as well. This is also the key for the many projects. So all in all, we do believe the combination of storage with PV will drive the decarbonizations. We also believe that green power will rapidly move to a wide range of industries, thousands of householders. So PV with agricultural, communication, transportation, medical care, education, commerce, and for sure manufacturing industry, all will be integrated. So we also develop, the battery system integrates with the solar system called 24 hours green power energies. So green electricity in our house is opening up for zero carbon life for families. We can see zero carbon power generation, zero carbon campuses, zero carbon homes, zero carbon data centers, and zero carbon networks. So yeah, that's from my side.
Sjors, a brief answer, if possible, please, to, in the absence of time, regarding storage as well. So what storage solutions do you foresee as being implementable on our road to 2050? If you name drop some.
Well, yeah, thanks, Alex. And I'll try and keep my answer short, but not before I thank the other panel members for the points they've made. And I particularly also want to call out, I mean, I think Mrs. Galli said it, Professor Korre said it, there are no silver bullets in the energy transition, right? We will need all of these different solutions, biomethane, natural gas, for all the different, and ammonia was mentioned. It's not like it's either or. We need all these things to get to net zero 2050. Yeah, and also at Shell, of course, we have that ambition in step with society. So I couldn't agree more, I guess, also with Mr. Zheng in terms of batteries. I mean, 2050, to your question, is still quite a long way away. But what we definitely see is that energy storage in the form of batteries, hydrogen we've talked about as a vector for storage, but in the form of batteries have a huge role to play. And I'd like to just lift out the example of Sonnen, which is a company that is part of the Shell group, but that has that puts batteries in people's homes, but then actually has, again, to the digital point, the technology to connect these batteries in these different homes to each other, so that the moment that one person is out on holiday, the other person can actually use the energy stored in those batteries. And if you then think about putting electric vehicles on top of that, you can see how exciting this sort of total network of solutions gets. So I can definitely see that playing a really big role in the road to 2050. Alex, thank you.
Very interesting concept. Mr. Fannon, I'm combining two questions into one for you, please. Apology for doing that. So the fact that President Biden has evidently greened up the U.S. agenda, the U.S. energy agenda, how does this affect U.S. interaction with the rest of the world, for example, in terms of U.S. LNG exports in the future to come? And the second question is that given the ongoing discussion, given that even our part of the world is focusing on energy transition, on e-fuels, on renewable energy, does this make all the conflict and all the discussion about exploration production in the East Med less relevant?
Great, thank you, Alex. So in terms of the greening up the policies, I think it's a win for U.S. LNG producers and U.S. gas producers because it's creating an incentive structure to improve the efficiency of operations, to bring down the relative emission profile for every MCF of gas that's produced. I think that's a good thing. I think as we see an increasing call for standardization for emissions, it incents and creates a premium for the more efficient producer and the one with the lowest carbon profile. So I think that's a win potentially. What we need to do is continue to push on transparency in the reporting of that, such that incumbent producers can't game the system. I think we have to be the energy transition, the objectives that we all seek, respective governments around the world. It's founded upon integrity, and it has to be credible. And so have that transparent system is crucially important. In terms of the development of the Eastern Med, I think it's all the more important that we continue to do so. As other panelists have shared, we're going to need all of these solutions. Gas also in that region in particular, I think it's critically important. I spent a considerable amount of my time as a diplomat recognizing that the halo effect that's occurring in real time, having these energy trading relationships, it has significant upsides in a variety of mechanisms. And the other point is that we're now, not all countries are starting the transition at the same point. Now we have meaningful infrastructure allowing gas to be transported throughout from Greece throughout the broad Balkans region and helping them to achieve their own relative ambition. So it's crucially important. And last point, I just want to recognize that the gas and the development of this gas in the region does provide the clear roadmap to the blue hydrogen potential. And you also have in Greece, I was pleased to tour the Kavala fields where we can see potential for injection and storage of some of that natural gas to ensure for a true blue hydrogen solution. So thank you for the questions.
And thank you for the very informative answer. You mentioned gas, that it's going to stay around, it's going to be necessary in the energy mix. And we also promised to talk about existing energy carriers used in an innovative way. Such an example is the downstream use of LNG, or otherwise called small-scale LNG. And I'm turning my head right to Mrs. Galli to tell us about how these applications of LNG are becoming available in our region through the infrastructure that you are about to commission.
Thank you, Alex. And let's say these really connect very well with what Mr. Fannon mentioned about US LNG reaching also Greece, because last year we have been really in our regasification terminal has received a lot of cargoes of LNG coming from the United States. And now this LNG not only will be able to reach, let's say, through being regasified the downstream market, both in Greece and abroad, but through the two investments that we are already implementing, it will be able to be utilized, let's say, through different, let's say, logistic chain. So the two investments are fundamentally, the first one is the truck loading station, which is under construction and will be operational, let's say, at the very beginning of next year. The truck loading station will enable LNG to be loaded on trucks, and through these trucks, this LNG can be utilized in Greece or abroad to serve off-grid customers, so customers that today are not on the grid that might be connected in the future or will remain off-grid for economic reasons. And also this LNG can be made available to become a fuel for trucks themselves, or as a CNG, of course, for cars. But in particular for heavy-duty vehicles, we know that for sure LNG today is the solution in terms of energy density that will really enable to rapidly decarbonize the heavy-duty transportation sector and all around Europe and, of course, also in this region. The second investment, that is the jetty. The second jetty will enable the reloading of LNG, like it happens in many other harbors in other regasification terminals in Europe, on smaller ships. And this is very relevant for Greece because we have many islands. We have many ports where this LNG can be delivered and stocked in ancillary tankers, and where again this can be used both for truck loading or as a fuel for bunkering services for the maritime sector, where again the, let's say, restrictions on the greenhouse gas emission and CO2 emission from IMO require quite a significant, let's say, substitution on more polluting fuels, and LNG is an available solution. And we see that in particular in the Mediterranean Sea and in the, let's say, in the Greek island space, the fact of moving toward an LNG system will be quite easily achieved because the ferries go back and forth, they have a defined route, and they can be easily refueled, let's say, in the destination or in the harbor where they start from. Other fuels will come. We heard about ammonia. There will be, of course, a future for other fuels, but LNG, in our view, is really the present for this off-grid solution and as a fuel for both the shipyard and so the maritime and the heavy-duty sector. And if we couple it with the biomethane production, that is will be really becoming, let's say, renewable fuel also for heavy-duty services.
It will definitely pave the way for bio-LNG and biomethane. And the last question, given that we have less than 2 minutes, is for Mr. Zheng, focusing on another already existing energy technology, photovoltaics, which is pretty mature, at least in my mind, as a technology. But the question is, how is this mature industry going to get more exciting in the future? What should we expect?
Thank you, Alex, for the last questions. So, over the next 5 to 10 years, for sure, renewable energy, we assume is a more prominent or important role as a main power source. So solar power has a particular bright future for sure. So, but however, the renewable energy represents a great portion of across power generation will become the important priority. So we do see that a few points that I would like to share with you. So we see that of the global PV plants will be digitalized, making it be simple, intelligent, and efficient management. The PV plants will great adapting to great. So inverter should therefore capabilities such as wide short current, and also can the rise through and fast different conditions. These are very necessary. And with the portion of coupled energy, also like 30%. So the power grid is for the regulation and the peak shaving. And the inverter power density will more than with lower COE for storms.
I don't know if Mr. Zheng can hear us. We can hardly hear you for the last minute. Although, it's an irony, although we've been talking about the merits of technology, it seems like technology has betrayed us at the very last second, because we cannot hear Mr. Zheng. But in any case, our time is up. Thank you so much, all the panelists that have joined us both physically and virtually for this, what I hope was a very insightful and interesting discussion on new energies. Thank you all.